All right, welcome back, everybody. This is the 2025 Virtual Residency Workshop, the 11th annual workshop. Today is Tuesday, June 24th, 2025, and our first session of the day is Facilitating AI in Academia, Challenges and Opportunities for Research Computing and Data Professionals. Our moderator is Tim Middlecoop, and I'm going to turn it over to Tim to introduce the panelists and get things going.
Good morning, Henry. Can everyone see me and see my slides?
Yes.
Great, thank
Yes.
you. So today's panel is on facilitating AI challenges, and we have our panelists here, and we're going to introduce them in a second. My name is Tim Middlecoop, and I'm a research engagement engineer at Internet 2. I spend a lot of my time within the research computing and data community. You may see me hanging out in places like the Campus Champions, CARC, USRC, and a whole bunch of other ones as well. So that's where I spend a lot of my time with the community. Prior to Internet 2, I was a research computing director at the University of Missouri. As we'll see, as Henry likes to say, a lot of us are failed academics, and I'm one of those. I had to give up my aspirations of being tenure track, and so I was a faculty member in the industrial engineering department, and I was traditionally educated in that, and I spent a lot of my time with technology, and I enjoyed it. And over the years, I had done a lot of work in a general area. And when I came to the University of Missouri, there was an open position. And I said, hey, I can do this. And hey, I might actually be good at this. And so that's how I got into the research computing and data community. Into the general community area, I got into it through my enjoying working with folks like you and wanting to help to support them. I found I was spending a lot of my time in these communities. So I'm going to turn it over to the rest of our panel to briefly introduce themselves as well. So Suresh, you want to go first?
Good morning, everyone. I'm Suresh Maru. I'm at Georgia Tech. So I direct a center for focused on AI in science and engineering. So in the last 2 years, we've been spending quite a bit of time and the challenges in AI for science and what we will need from the cyber infrastructure and computing and how we should provide that support across the campus and through other national NSF funded projects as well. Before I started this 2 years ago, I was spent a lot of time at Indiana University, and where we were primarily focused on developing and operating science gateways, and through that also the NSF projects like Exceed and TerraGrid. Before that, where we were looking into how to provide advanced scientific consultations for science domains across the board. So with those perspectives and what me and my group is right now looking into is what does AI bring in? What are the challenges here for RCD professionals in general? And how do we better support AI for science? So I'm looking forward for these conversations. Yeah, thank you.
All right, Menas Rana. I'm sorry if I mispronounced
No,
your
it's
name.
okay. It's okay. Good morning, everybody. My name is Mario Fana Milanova, and I'm professor in computer science in University of Arkansas. Before to work in the university, I actually work in industry. My area always is artificial intelligence, and I actually work also like a certified instructor and ambassador for NVIDIA. And this is what I actually want to encourage people to um, uh, take advantages of whatever NVIDIA offers, and you will see in the presentation in the future.
Samir?
Thanks, Tim. So, hello, everybody. My name is Samir Sarilich. I'm a doctoral candidate currently at Vanderbilt University. And to just leave it off at the doctoral candidate, I feel I'm being a little bit pretentious. So, to just tell you a little bit about myself, I've been in RCD for a little over a decade. I've held appointments at Georgia State University and more recently over at Georgia Tech, where I've held a couple different leadership positions across different teams. But at the heart of everything that I've done over that past decade or so has always been enabling research on research computing resources. And that's been really like, at the heart of everything that I've done. I've I've had a very kind of serendipitous journey into research computing. Uh, as a researcher and graduate student over at Georgia State, I started in geosciences, and next thing you know, I'm doing this GIS work, and I can't get it done on the workstation. And I get pointed in the direction of these larger resources, and I'm like, okay, what's that? And then you start working with Linux and Bash, and next thing you know, I just get sucked into the world of supercomputing. And I got to say, it's been quite the joy. And working with lots of different researchers from various disciplines has been probably one of the best pieces of this particular work that I've done. So right now, I really focus on AI as part of my work, and I really look at the socio-technical challenges that we face in the midst of this AI age that we're in right now. So I hope to share some of the stuff that I'm currently working on, and I also look forward to hearing some questions from y'all and additional input. So thank you for joining us here, and glad to be here. Back to you, Tim.
Ying, you're up next.
Yes, thanks, Tim, and good morning, everybody. I'm Yin Zhang. I from University of Florida, and I'm the IT manager for the AI and research software engineering services at Research Computing under UF Information Technology. So my background is in high performance computing. I've been working in this field for probably for decades. So currently, my focus is on providing state-of-the-art AI services to our UF community. And UF IT Research and Computing manages and operates the supercomputing cluster Hypergator. Not sure if some of you have accounts on Hypergator because we offer to partner institutions too. We also provide high-performance computing services to UF community and our partners. As I said, our AI team designs and develops AI services and solutions to support our UF cutting-edge AI research and education. So UF actually started our AI initiative in 2020. So I think probably a little bit earlier than other institutions, I should say. So in the same year, we also established the NVIDIA AI Tech Center at
Hello, how are you? I have an appointment at 10:45. Amy Yamasaki. I'm very early.
somebody probably need to move to the mic. Yes, I was just saying that we also in the same year, we established the NVIDIA AI Tech Center at UF. Probably is one and only NVIDIA Tech Center in North America right now. So in the past 5 years, we definitely see a very strong demand for AI, of course, resource and services support for our campus. Our researchers usually come to us not only for accessing computing resource, but also for guidance from AI project planning, for example, resource planning, model software selection to software development, scaling, optimization, troubleshooting, all kinds of questions. So we have worked very closely with the research groups on numerous AI projects across research disciplines like physical science, medical research, engineering,
I'm part of
and
academic
arts and
IT, so I
humanities.
work primarily with basic science.
And really played, our team definitely played a vital role in advancing AI research and applications. So we also develop and teach AI training courses at different levels, including NVIDIA DOI courses that Maria Fana just mentioned. So our courses usually very super popular and definitely from fundamental AI skills to advanced AI application development. So I'm super excited to be here with my other outstanding panelists and discuss the challenges and opportunities of AI research and education facilitation, and to share what we have learned. And I definitely love to learn from our other panelists and from your audience as well. Thank you so much.
Thank you, Ying. And finally, we have Paul, and a special thanks to Paul for putting together this panel and helping develop some of the materials in the background. So thanks for your work on that. Paul?
Thanks, everybody. I appreciate that. And welcome all. My name is Paul Brunk. I'm a HPC system administrator and have been for 20 years at the Advanced Computing Resource Center here at the University of Georgia. I've been a Unix sysadmin since the fall of 1992. At that time, I came to the University of Georgia after my first year of grad school in philosophy. I came here to Athens, Georgia, to get my 2-year master's in AI. Tim referred to failed academics. I was at ABD on that, never quite got the master's. But I did get exposure. My grad assistantship was to be a sysadmin in the AI computer lab, which is what the other grad students and the faculty used. Computers were not my background. So I learned by the immersion method. And by the following year, I was the lead sysadmin. Just it was a 2-year program. Everyone else was in their second year when I got there. Since then, between that, before the HPC stuff that I started 20 years ago, I eventually was at the enterprise level of doing things. But around after AI, I worked for various life sciences departments, and in one case, worked directly with a PI on a plant genetics grant as the computer person. So that's kind of the facilitation that I've done. Lately, I've been more facilitator adjacent. I have been through the Colby's Cyber Ambassador program and hang out with fine people like everyone here, not just the panel. What led me to develop the interest in facilitation is where my school is. Last year, we're undergoing an onboarding, somewhat phased onboarding of a whole bunch of earlier mid-career AI using researchers. And our HPC shop said, gosh, what do we still need to know in order to facilitate the onboarding, the ramping these people on? What do we need to find out? What do we need to buy? We need intelligent, reasoned approaches to answering that. Dove into this facilitation aspect of this stuff. And that's still ultimately what, self-centeredly, that's still what I hope to get out of ongoing working with everybody here. We're all in this together. Back to you, Tim.
Thank you, Paul. So we're going to go a couple slides, talk about the aim of the panel and some shameless plugs. As you can see, we have a diverse background of individuals. So I'm looking forward to some lively discussions with different perspectives. And we also want you to get involved as well. So you can either put your question in the chat or discussion in the chat, and I'll relay those to the panelists. Or if you want to chime in, please just raise your hand, and you can ask your question or add some comments as well. And as you know, AI is a hot topic, so I'm sure everyone will have some great things to talk about it here. Let's see. Let's talk about the next slide here is on the AI Facilitation Materials Working Group. And this is a lot of the folks here are on the working group. And it's a collection of folks within CARC. It's a working group, so we're working on products. And our aim is to develop resources and training materials to help RCD professionals, so not researchers, folks like that, but it's RCD professionals to effectively facilitate the use of AI technology. So one of our big target audiences is facilitators, like many of you on the call, that are getting into AI. So you have experience with the facilitation process, but not necessarily AI. And so how do you wrap your brain around it? What are some good resources? How do you get trained up? What are some good resources to get trained in? Those types of things. So that's what we do. We meet weekly and we're developing materials. We basically started in the beginning and said, okay, what is the common language within AI? What are some of the words that we use within research computing and data as it relates to AI? And that quickly evolved into, what is the process? And so we wrote a paper, AI Project Facilitation Guidance for Research Computing and Data Professionals. And it's all about the AI project lifecycle. What are the things during the life cycle, some challenges from an RCD perspective. So come join us at PERC if you're going in person. And if you have any questions about that after, make sure you ask. So that's there. Also, I'm going to hand it over to Professor Milnova to briefly introduce NVIDIA's DLI program, which is another good resource for AI.
Yes, thank you. Thank you, Tim. So like Professor Zhang mentioned, the interest about Deep Learning Institute and what they offer become really huge right now. We actually, Samir, prepared a PDF presentation about the requirements and procedure to get the certified instructor or ambassador. Here is for graduate students. This impressed me that even the master students or PhD can get the certificate, but it's kind of difficult for students. More easy is to get the certificate for faculties and researchers. And the benefit is really huge because they can get the teaching kids, they can get additional even grants. All of this, I think, is in another presentation, and if you have more questions, I will answer. So my personal experience and experience from participants, we actually, every company, almost Amazon has the certificate, Google, of course, Coursera. But here, these certificates it's interesting because the courses are hands-on with a lot of additional resources. So it's very well organized, very, very, very useful for people to pursue this. They can become developer only also and use the courses, whatever works. But for the researchers, I really recommend them to become a certified instructor because they can spread the knowledge and educate a lot of people. Okay, so I think that we have additional material how to do it. There are particular many areas actually for accelerating computing, for high performance computing courses, for data science, for generative AI courses, machine learning AI, large language models. So variety of topics. Also graphics, computer graphics, if some of our colleagues are interested. Thank you so much for now.
Great, thank you. And make sure you check out that resource. So I'm going to put up some questions. We have a couple of prepared questions. We'll go through one or two. Feel free to add follow-up questions or discussions on that. And we don't have to follow our panel discussions directly, but it's just meant as a guide to get us started. So I am going to start off with the question, how can RCD professionals effectively guide researchers in selecting and procuring appropriate infrastructure for AI workloads? And Ying, I'm going to start off with you to kick off the discussion.
Certainly. Thank you, Tim. And this is a great question. It's very on point. So that's really a lot of our time is spent on guiding the researchers in selecting and procure or infrastructure can be hardware and software. So we worked with a lot of AI projects with different workload and workflows. So be aware that the researchers can come from very different background with very different skill set. And most of them probably not very well versed in the computing. So they definitely need the guidance on selecting the type and amount of resource, software stack, and so all the very key elements for AI research. So I would just say that at the beginning, I would suggest to get as much information as possible about the projects. I can say there are like 5 questions probably are key to ask. The data, so data source, data type, data size. If the data is restricted, HIPAA or FERPA restricted, that will indicate if you need to go through compliance process or procedures or risk assessment. And then so that's the data. And then also type or the size of the AI models they want to use or they want to develop. And then the third question I would ask is what software stack they are considering. And if they don't have an idea, you might need to make some suggestions. And also, what end product or workflow they're planning. And then the last, but that's very important, what's the budget? So, which is sometimes can be a limiting factor. So with all this information, then you can start to estimate computing resource, hardware resource like CPU, GPU, and storage. In some cases, you might need to think about network if the resource is not in your facility within the budget. So, so usually the size of the data might determine the minimum amount of storage the user may need or the researcher may need for the type of the model. So some research group, research projects might want to develop their algorithm or models from scratch by themselves. Some probably will use, actually that's most of the cases, use existing models, do fine tuning or retrain those existing models. And the type of model, if it's a deep learning model, most likely they will need the GPUs. So especially if it's like large language models, they will probably need more than one GPUs. So, and then for the software stack, you can see whatever the software require, if they're good fit with your, for example, we have a supercomputing system. So if they're good fit with our system, for example, our system is all Linux shop. So if PI comes say, oh, I want to use all this software, they only works for Windows, then we have to recommend some other resources instead of our own environment, for example, cloud service or something like that. And the end product is very important too. So we have researchers who want to train or fine-tune the models. Some researchers want to use the existing models, build an AI agent. So I know everybody knows AI agent is big buzzwords now. So people build AI assistants, AI agent, they want to deploy on a web portal for public use. So then you have to think about, do you have a resource to hosting a AI agent or AI assistant, those like web portal resources. So the workflow also matters, because if the project is huge, they have different teams working together on the same project, then you might want to set up ML ops basically is a machine learning workflow management system from data processing to model training to testing and model management. So that also depends on the size of the project. And so I think that will be like 5 key questions you would like to ask at the very beginning. And so for us, because we have a state-of-the-art computing system, for example, we had NVIDIA A100 SuperPod for 5 years, and now we are actually installing the new NVIDIA Blackwell B200 SuperPod. So we never had a need to go out of our resource to secure cloud resource or buying individual workstations. So for some PIs, the project is small, they probably want to buy their own just GPU workstation. But on our system, we have enough. Usually the work we do is just helping them estimate how many CPU, how many GPU, how much storage they will need based on the information you get from them. But I think one thing I would like to, last thing I want to emphasize is that to be an effective AI facilitator, I think it's very important to stay on top of the AI trends, technologies. As you all know, AI technology evolves very rapidly, and the researchers that they come to you, they depends on your expertise on choosing right tools and the right infrastructure. So I think that's very important to just get your skills up so that you can effectively helping researchers. One thing I would like to mention that I'm sure Maria found are very familiar. So for NVIDIA, it's not just a hardware or chip company. It has a very robust AI software ecosystem. So they have a lot of AI software tools and platforms that are highly optimized for NVIDIA GPUs. So for example, we have a lot of AI projects in healthcare, medical imaging. NVIDIA Moonlight or BioNeMo are great platforms for medical imaging and develop drugs or do trials. So those are very good resources as well. I think I can stop here.
Thanks, Ying.
Yes,
Yeah, I started off with you because I knew, given your background, that you'd have lots of good things to say about the facilitation process. Now, you mentioned that training is really important. Samir, what are some of the resources that you use? We'll start off with you to stay up to date. How do you stay up to date with AI? I mean, obviously, going to well, maybe I'm incorrect, but looking at journal papers might not tell you the latest in technology because everyone's kind of ahead of the publication process. Where do you go, and how do you keep up the speed with what's going on in the AI process? With, of course, a tinge towards RCD facilitation and just AI facilitation for RCDs.
Excellent. Thank you for that question, Tim. Spot on. The way that I approach it is I look to see what's going on in the community. If you were to take a look at my Slack and some of the other channels, it's like out the wazoo. And I don't even have time to keep up with everything. But it's all about keeping a finger on a pulse. And to everything that Ying said, I would say yes. And I would really emphasize the listening part. You got to listen to the community. You got to listen to what they're actually discussing, because a lot of times you're going to hear some of the new trends that are taking place there. And at the same time, there is even going to be things in your own institutions that might be taking place at the higher level, institution-wide, that might be just a little bit something that you didn't quite see coming. And it's like, wow, that's amazing. I remember when I came over here to Vanderbilt University and AI was really a big thing. And then all of a sudden I hear about Professor Jules White, who is spearheading the effort in setting up a chatbot for the entire campus and opening it up to the entire community, the students, the faculty. And that was something that I didn't actually pick up from listening to some of the chats that are taking place within ACRE, which is the research computing over at Vanderbilt. And this is something that actually I got it from a different channel. So you have to really have your finger on a pulse everywhere to kind of stay abreast. And the other part that I really wanted to add to what Ying was mentioning when it comes to facilitating these activities, as a facilitator, it's really hard to just come in there and have all these questions that you can script and just ask, and it'll just work for every single research group. And one of the things that I've actually found very helpful is to really kind of tap into some of the analytics that we can also take advantage within our research computing center, like XDMod. It really gives you insights into some of the behaviors of users and how they're using the resources, which then inform how some of the new research groups in similar areas might actually be using it. It is not one-to-one. It is not a prescriptive approach. You still have to kind of adjust and pivot as needed, but it is a good starting point. It helps you basically embrace that data-driven decision making when it comes to approaching some of the new groups, because they might come from a long tail of science where they might not have the heavy expertise in research computing. So they might come to you with a wish list of a large amount of resources, when in fact, based on some of the patterns that you've noticed in those disciplines, they might actually be able to get by with a smaller resource, or maybe even route them into a shared type of resource rather than having them invest heavily into a dedicated type of resource. So this, again, as I'm kind of touching on these dedicated and shared resource, it's touching on various models that might vary from campus to campus. Some of you might have strictly a condominium model where it's a shared type. Some of them might be dedicated, or you might be like Georgia Tech, where they went down a path of more of a cost model that is akin to cloud, where everybody's got an account and they're able to charge for the cycles that they use. And they still also take advantage of some of the free resources through accounts that are provisioned to users. But it really kind of depends on use cases at the institution, as far as the center that is providing resources, as well as the unique research needs of the researchers, which again comes down to having to really sit down, listen to the researcher. Don't try to saturate and suck in all the oxygen from the room as you talk. Just let them really tell you everything about the research. Ask those probing questions to get as much of that insight, and then you can kind of make those more informed decisions. And even then, with some of the specialized cases and some of the, as we like to sometimes refer to, bleeding edge research codes, we might not be able to make the best educated guess. And sometimes we've had to resort to hey, let's bring you into a sandbox environment. You try running that stuff, and based on what we see right there in that environment, then we can have a conversation as far as what you might need. So there's always going to be some of these edge cases where you just have to kind of spend that time, and above all, be patient, because whenever you're trying to do something new, sometimes it takes a hot minute before you can actually make some progress. I'll stop there, as I don't want to suck up too much oxygen here. Back to you, Tim.
Thanks, Samir. I'd like to get some perspectives in from our researchers. So, we obviously cannot ask them the same questions, but I'm sure they have their own perspective on the infrastructure and how best to run their codes and things like that. And so I'll ask the question, and I'm going to ask first of Suresh, is what do you find about AI workflows and research that is different from what you've experienced in the past? For instance, infrastructure, tools, things like that. How do you find working in the AI sphere different from working in a different sphere of research and what you've done in the past?
Thanks, Tim. I think that's a very good question. In fact, right, so many of these facilitations, we have to go back to what we already know before we kind of all, as Ying and Samir were discussing, before we figure out how to navigate the unknowns or fast changing fields. Like, we have to build from what we know. I think, like, from what I think we all probably are experiencing the same thing. The fundamental difference here is, like, and I think in the HPC community in general, computational heavy, you always were used to doing, like, generating data from computations, and then, like, we're figuring out, like, how do we fill up the computing and then provide associated storages and data and all. Certainly AI reverses that part, like, that certainly we start out with the data, and then, like, you consume data before computing. So that's certainly the I would say the cross-cutting thing you see across, like, different things, whether you talk about training or inferencing, or, like, what you're, like, fine tuning, like, you'll certainly see this aspect, which is somewhat relatively new to us in that sense. Like, there were, like, examples of that, but largely that shift is very big. Like, you start out with the data and then, like, keep evolving, and how do you keep up with that? And then the other related aspect, like, is if you overly summarize the workflows in the HPC, like, or pre-AI Hypera, we were always used to using sweeps of, like, parametric sweeps of models or applications or whatever workflows, whatever we will want to call, and used to running those. But, like, the one thing we see the AI brings in is there's so much of exploration of which model works well, and then that requires the amount of interactivity and how the amount of researchers involved in that entire every step of the workflow has changed, has increased quite a bit. There was interactive needs all throughout, like, in but various stages, but previously those interactive needs were the heavy interactive needs were in the early stages of a research workflow, and that was needed lesser computing, and so better done on users machines, local accessible machine. And then you do the heavy batch computing, and then there is some interactivity there too. That's what we were used to. But now we see this, because of this, you'll be exploring which model worked well, which what's happening, and all of that. That interactivity demands have increased quite a bit. And then there is the third aspects. The first one was the data one, I was saying. The second one was the interactivity. And the third aspect we see a big change here is, given with anything new in your systems, like, there's a lot of things we need to learn. Take as an example, AlphaFold. Okay, we see a lot of a big community saying, okay, I want to run AlphaFold, and by default they will look at Hugging Face or other papers and say, I need so many GPUs. But if you break down that one, and, like, we see that a lot of post in other places, like, once you break it down, you will see it has a heavy bioinformatics component, which could very well run on CPUs, and then somewhat like the deep learning model aspects need to run on GPU. So doing those kind of learnings, like AlphaFold is kind of more widely used, so you can build that. But how do you do that for across the board with lots of emerging ones? How do you break down the black box models and then allocate appropriate hardware and all of that? Like, so basically the amount of complex workflows we deal with are changing, like, and so that's like there. And I'll stop at the last one more. So what we used to see in this classical computational science was, like, once you set up your module environment dependencies, that remains constant to the computing. In these AI models, like, from a research perspective, what we see is there are these complex tasks, and those life cycle within this life cycle, you will see those dependencies are changing because you're coupling so many different things. Each one will have to have different dependencies, like, you're loading up and unloading and often conflicting and so on. So I think that's certainly the new complexity, like, we are all wrestling with. And yeah, let me pause there. Yeah.
Thanks, Suresh. You mentioned interactivity, right? So that means, like, some of the infrastructure is changing. Paul, as a sysadmin, you're going to have some good perspective on this. How is the technology and infrastructure different, right? There's the hardware, obviously you have GPUs. What kind of impact does that have? The interactive software. What are some of the things that come to your mind when suddenly you're supporting AI workflows that you've had to adapt to, that people that are doing facilitation should be aware of?
Thanks, Tim. I'll knock off some of the routine, to me, sound knee-jerk and easy to find resources about answers, such as power, cooling, and things like that. Talking, from an infrastructure perspective, um, with an eye toward little background. The way our shop works is part condo and part whatever the term is. There's the only barrier to access is you have to be a researcher at the university. So we have central funding to provide the hardware and other staff and physical resources needed. However, researchers can and often do purchase their own hardware. It gets added to the cluster and condo-like. It is available to other users unless the owning user's lab wants it, then they get it. So I see an over when a researcher says is pondering what hardware do I need? Here's what my research campaign looks like to me. Here this look like what the PI, see as a computational description of its resources, the data needs and stuff. Hey, you AI hosting center, what else do you need to know? As I mentioned in the intro, we were bracing for having to answer that question for new researcher upon new to us researcher upon new to us researcher, maybe a couple of dozen in 2 years. So I thought I better become literate right quick. The idea of sizing problems to hardware in general, is not new. It was not new to our shop, certainly. But we wanted to know, okay, we're up against power limits, money limits, time limits, etc. We need to shop wisely, especially since in some cases when we buy, it's for the rest of the user community that doesn't get the grant, the non-condo users. So we have to think about not just what does this PI need, but what should we buy for the whole campus community as a whole. It still comes down to sizing and scoping, but from a slightly different slant. So I set off to say, okay, using previous sizing scoping that many of us have done before, said, okay, what are the specs we need to know? Flops, are these still useful, but not so much in this domain? Tops and relatively new, useful, but no one size fits all. What I wanted to know is, hey, how can I learn how to take the computational needs that the researcher provides, perhaps with the help of our support staff, translate that into some meaningful hardware description, whether it's flops onto RAM, whatever combo of stuff is needed so that we can accurately do purchasing. What I learned during that, as a side note, was that was at a time when Gen AI was hitting the outside world. And so there's a lot of material available about sizing and scoping. A whole lot of it is of little use for the purposes of us academic facilitators, because it's aimed at either one-stop shop products that happen to use Gen AI for whatever purpose, typically enterprise or personal assistance, or all that stuff. But that's a lot of money in that part of the AI market, as opposed to the research domain we're talking about. So there's a lot of material made for it, and sometimes, as you'd expect, some labels and terms, deliberately or not, get fudged, get overloaded. So us consumers of that information, it can get difficult to navigate. A year or so ago, I said to a couple of vendors, Intel, I don't remember who, and I said, hey, if you want to get more mind share from shops like us, which are not giant, but always lifelong learner. That's how do we stay on top of it? To touch that question, lifelong learning our only hope. We would like to educate ourselves based on your something better than your sales brochures, better than your white papers, but also better than for the stuff you have in the AI market. Don't just wow us with benchmarks. If you're not, Intel are not selling systems to us, I know you're telling your resellers how to answer these kind of questions. What can you share with us about that? I choose Intel as one example. They actually have done much along those lines. So as has NVIDIA, huge increase in the amount of self-service courseware designed to expand mind share, but not in a vendor specific way. From one vendor's perspective, including their ecosystem, but the principles involved are the same. So I learned, try to ignore the commercial or enterprise-based AI hype when getting through here. I still don't have the answer. Our working group to finish up our working group still has as an upcoming desired thing to actually develop a guidance on how to get from the stated computational needs to what hardware should I buy. That's my perspective. Go find the material that you can possibly have the background to consume from the vendors themselves. Hang out with community like you guys, and well, that's it. Thanks.
Thanks, Paul. You mentioned scale, right? Scale is different in AI, or can be different in AI than a lot of other problems. Um, uh, Professor Milanova, question. How does the scale of AI differ from traditional HPC or HTC jobs? And what are some of the challenges that you face from an RCD perspective when dealing with that scale, explaining that scale, handling that scale, those kind of things? How do you deal with scale in AI, and how is it different from, let's say, HTC or HPC? And what are some of the unique things that you should know about AI workflows and AI problems?
Well, yeah, I don't know if discover the scale, but the scale that AI is growing so fast and covers not only uh, researchers, but also different educators, like chemist, not only chemistry, but writing, English. So what we do, actually, we do kind of seminars. We did recently hackathon. We do blogs, and we have a lot of discussions about what is possible to do with generative AI. In our institution, in our university, actually, we create a own chatbot with secure information about the students and the researchers and everybody. So it's using RAG, retrieval augmented generation approach, and generative AI. So this is what I will say. We have to educate many, many people in the university or outside the university, the community. So it's very, very hard work for all of us. Obviously, you know this. So I suggest to have more seminars. We have a blog also, newsletter, blog, seminars, and hackathons. This is what we organize for community. Thank you.
Hey, Tim, I don't know if you're available right now, but we do have a question from Austin in our chat. Do you want to take down one now? Happy to do it. I'll go ahead and take that. So, Austin, that's a great question as far as how do you approach resistance to AI innovation and research facilitator teams and CI teams? I'm going to take a stab at it first, and then I'll turn it over to our group to also chime in. But anytime that you're approaching a change, you have to start by socializing it. And you started with your smaller group, your power users, your most influential stakeholders, the ones that can actually sink an idea very quickly before it even takes off. So you start small, and then you start buying in that support and basically pretty much raising a coalition on the campus before you can actually start making a massive change across the scale. So that's how I would kind of approach it. Start small, socialize it, and then bridge it from there. Others from the group, please chime in as well.
I can chime in. So I think University of Florida is a little bit unique because we had this huge AI initiative. So from top to bottom, so that's the initiative is across the campus, from every discipline, from every college. So really had the support from at different levels. So initially, we definitely encountered, so we have this AI support team. So we definitely encountered challenges. People have doubts about AI. I think that's very normal for any new technology, new industrial revolution. I have to say AI, perhaps it is a revolution. So, and I guess, first of all, you definitely need the leadership support. I think I I don't think we should avoid that. I think leadership support is the key, and then education. I really like the education idea and the training. And I have to say, nowadays with ChatGPT a few years ago, I do not know if there's a single person not using any Gen AI tools. So I think also the results says the thing. So there are so many grants, so many grants calls also focus on the AI. And for example, NSF, NIH, they really put a lot of emphasis on AI and the new initiatives from all funding agencies. And that's also the evidence to show AI is the reality. So I think that's something to go in the, yes, I think, of course, I think I will stop here. I know there are questions about challenges or lessons. I think, yeah, we can share later.
Yeah, thanks, Ying. Sorry I just stepped out for a second there. So now that we've had the kind of first round of questions, we're moving into the lightning round section. So the panelists, if you could keep your answers as short as possible so we can get a lot of variety of questions and some discussion. So we're in the lightning round, and soon we're going to get into the double bonus point round as well. There's a question from chat that I found was interesting, and so if we could get a couple sentences from everyone. About novice users, right? I imagine a lot of us get people that, they've heard of AI, they've used AI, and now they want to integrate it in their research. They may not have even, know what an HPC system is or know about the technologies. How are you going about educating novice and intermediate users? Someone want to jump in?
Yeah, this Suresh. I'll start, take a stab. So I guess it depends on how we look at it. Again, if you're talking about educating the novice or intermediate user about use of AI or what is AI, then that's a different question. But I will particularly focus on, okay, how do we apply it to science, and what is the AI for science needs there? So the way I look at it, I think I see there's a lot of other questions on, okay, I don't trust this, or how do we navigate this part of it? Is it explainable? Is it really usable, and all of that? I'll just stop by saying a simple analogy. The way to look at it is, I think, and what the way we also teach for the novice parts is, I compare it with the car, an automobile, we have shifted from manual gears to where we trust using the clutch on how do we shift gears to slowly we started driving the automated gear shift. So now we don't need to say, look at AI as, okay, here's an autopilot, I left it to drive, but instead take it in an approach that, okay, I use it only to keep me in the lane and be closely watchful for it, or keep me in the adaptive cruise control mode and then see what it is. So same thing, we approach it for the novice parts too. We take it bit by bit and see what aspects, where they spend a lot of time, and see, okay, if there are solutions where they could closely watch and build understanding on where they are good at, where they are not good at, and then how do we learn that aspect? They do good job at this, they don't do a good job at it, and how do we navigate that is the careful approach what we take.
I
Yes.
could go next. Oh, sorry. Samir, please go ahead.
That's okay. Okay, thanks, Ying. So the part that I actually wanted to chime in is if you got a large base of Novus users, especially lots of students that are trying to explore and really get their hands dirty with AI. you got to look at it from an institutional aspect. In this case, you're going to have a lot of folks that are going to be doing a lot of prompt engineering. They're going to also be uploading lots of data. So as an institution, you got to start looking at, okay, what is the risk that we're taking on as an institution with so many of our constituents right now starting to put data into these third party sources that are providing these chatbots. So as an institution, you got to evaluate that risk and come to a decision whether you're going to make a service that is accessible to your entire institution. So that way you can put the appropriate guardrails and try to bring a little bit of sanity to this AI and really kind of embrace that responsible AI aspect. So that is in a sense that you are keeping the data within your sandbox environment at the institution. None of that data is leaving out. You keep it in, you're the custodian of it. So you minimize the risk. And at the same time, there's also the intellectual property aspects that also come into play when you're working with the AI. Who owns that? So what are some agreements that the institution can start putting in place? This is kind of around the time, or maybe it actually happened after I ended up leaving Georgia Tech, but I believe maybe Suresh can touch on this. But they should actually have a really interesting intellectual, the IP aspect with Microsoft in a way that the actual researchers retain that IP, or in this case, Georgia Tech retains IP for any outputs that are coming out of the chatbots. And this is something that a lot of other institutions are doing in a different way. I can comment on some of the points, and this is at the user level aspect at Vanderbilt. For example, this institutional chatbot that is available that leverages Amplify for providing the service, all that data basically stays within Vanderbilt's jurisdiction. So it's in that sandbox environment. There's that aspect where we have a little bit of more control rather than just putting in some other external provider. I'm going to
So
stop
Samir,
here, and I see a hand up. Go ahead, Tim.
yeah, thanks. There's definitely issues when it comes to the enterprise and the institution with AI. We're going to try to focus on, the research part of it. I know it's easy to get distracted and to sort of draw the line between, okay, folks that are using AI and folks that are, using AI for the research as well. Nabil, you had a question? You want to unmute and speak?
Can you hear me?
Yes, we can hear you just fine.
I just want to add something quick for beginners and novice in AI and HPC. I developed about 14 workshops. It's actually designed for high school student who doesn't know anything about HPC and AI, and I put it in a wiki, and I also put it in the link in the Zoom chat. They start from scratch, from zero, assuming they don't know anything, and actually the language is designed to engage students using emojis and simple language. So of course anyone can use it. And I actually write a paper and submit it to PERC, and it was accepted. So I'm going to present this workshop at the PERC conference. So this is just a contribution for anyone who is super new to AI and HPC, to explain in very, very simple language, very simple terms, AI, and first how to apply AI concept using PC, their personal computer first, then how to use HPC using Access, the NSF initiative, so they can access supercomputer after they finish using the same workshop in their personal computer. So I just want to add that as a available resource for anyone. Thank you.
Thanks, Nabil. I think you read my mind. My next question for the panelists, and I'm going to restrict you to just one resource. If you were to suggest a resource for new RCD professionals and or new researchers into the field of AI, where they're going to be, developing their own AI code, what would that be? And you cannot duplicate one of the previous panelists' ones. So one resource only, and I'll start off with Paul.
If it's specific, if it's specific to coding, I'll say I'm probably at least qualified to say, although I've taken some classes. I am, for example, I did the NVIDIA DLI Fundamentals of Deep Learning during COVID. GTC became online, and that was my exposure to the current AI. So that I know that they are an excellent resource specific to coding. There are others too, but if I had to, desert island, easy navigation, that kind of stuff. I had a PyTorch Foundation and things like that also have nice documentation sets.
So if you get a chance, Paul, can you put the link in the chat for folks and explain what is GTC for those of you who?
Oh, sorry. In NVIDIA, I think I don't know what they call it now. I think it's still GTC. It used to be the GPU Technology Conference. It's an annual mega blockbuster event, especially now. Now it's more commercially driven, by the way, but it is nonetheless a showcase for what can be done with AI and how.
Still is GTC and everywhere in Paris and China and here they have different events. So yes, still GTC.
And so what's your number one resource? And Paul stole GTC on you there maybe, but so what's another one that you would pick?
You're asking me?
Yes.
Yeah, I already say I'm working with NVIDIA and I'm very pleased, and I think many of our customers and collaborators also are very, very pleased from what NVIDIA offers.
So what resource would you point folks to just getting started in AI? Is there a particular lesson? Something like what learning material would you use?
Well, they can start with Deep Learning Institute, okay, and see what is related to them, like maybe deep learning models, maybe large language models, maybe something just rapid, like a data science models. So they can start with Deep Learning Institute, but like Inc. mentioned, the software that the NVIDIA also offers, like Hugging Faces, similar idea of Hugging Faces, they have a microservice. So they have own models or third-party models that people can use with API keys for their research. So there are many possibilities. Means if they are new, or start with classes and learning. Many of the classes are free also with the certificate. So there are many opportunities for learning and also for researchers to use microservices and already created models.
Great, thank you. Samir, I see you're unmuted. What is your one resource that you would point folks to that has not already been mentioned?
Thanks, Tim. So I'm going to lean into my past experience within facilitation and the many HPC workshops, monthly workshops that I've facilitated in collaboration with PSC at the various campuses that I worked at. So, for example, PSC hosts these monthly workshops. Some of them focus on OpenMP, they'll have big data, and right now they even have AI. But one of the other things that they really do well is they give you hands-on experience on using their resources like Bridges, or I should say Bridges 2. And you can actually apply some of those codes and get some hands-on experience in doing AI. So I would suggest checking out PSC's HPC workshop, getting some hands-on experience with Bridges 2, running some of those codes, and really kind of taking it from there. Tom Maiden and John I think they've done a really good job over the years in facilitating that throughout Exceed when I actually collaborated with them. And right now that effort has also taken off through Access as well. So I welcome others to also check it out. Back to you, Tim.
Suresh, what is your one that you would add to that?
Yeah, I think I'll just put like a clarification that like I think lots of these resources, I think it'll be good to bucket them into two categories. And recently, a faculty from MIT was categorizing this as, are you an AI astronaut or an AI rocket scientist? Like, kind of a word. So I would say there is some of this, like, if you're trying to be a researcher in AI, advancing AI from a CS, and some of the Coursera things like AI for everyone from Andrew NG and all will be good. And there was this Hugging Face Learn module pointed out already. That'll be a good one to try out as a user and as a community. So I'll just underscore those two again.
Great, thank you. And Yang, I will leave it to you last.
Thank you, team. I agree with everybody, all the panelists' suggestions. I think as beginners, we actually have a lot of beginners come to us asking about the same question. How do I get my project to start? Where to start? So I think I agree with Suresh, there are just different categories. I think depending on the background, depending on what they do, I think that's the two things we need to distinguish. So from arts and humanity, they know nothing about coding. They just have no idea about computing. And for some researchers from traditional high performance computing community, for medical research, they just want to use right AI tools to get the project started. So the recommendations will be very different. So for people with no knowledge about coding, with no knowledge about AI, we actually created this practical AI training material that really is for people with zero background in AI or in computing. It teaches all the stuff from zero, level zero. So those courses are super popular, and it's not only available to UF, but also available to everybody outside. And NVIDIA DLI resource, they are very, very good, but I would recommend that to second category for researchers, just want to choose the right tools and the right models for their research. I think NVIDIA has a great resource for that. Not like Hugging Face or that might not, they're all very general, but I think NVIDIA's DOI has a very specific focus on different research domains. I think those are good resource.
All right. Any other contributions to getting started? While you're thinking of that, I'll mention that that's one of the things we're working on in the AI Facilitation Materials Working Group is coming up with a list of curated ones. So part of the exercise was here to see if anybody in the audience also has some good things to get them started. So that's one of the things that we're working on. I'll give one more on this topic, and then we'll move on to the next topic. Anyone have one they want to say? Okay, I guess we're all learned, right? I guess I'll give you mine since I actually haven't given you my opinion. My suggestion is to learn PyTorch. There's a lot of good resources out there, and they do it in the context of AI. So they teach you what a tensor is, and they do it in the context of an example, and they take you through it. There's a couple of videos online that I highly recommend. If you're learning, my opinion, if you want to learn more about neural networks and things like that, 3 Blue 1 Brown podcast on YouTube. Grant Sorensen, I believe his name is, does a wonderful job of visualizing maths. Not only that, a whole bunch of other things. And it really brought to my mind, okay, what is an LLM? How does it work from visually? Very well done. So highly recommended to add that to your catalog as well. So, and Andrew Suresh, he does an excellent video as well, and I'll drop the link in there. All right. Do we have questions from the audience? Let's get a question, one or two final questions from the audience.
Or tell us what we said wrong. Whatever.
So this is the interactive session. And I'm going to lean heavily on the awkward silence. Yeah, Dan has been talking a lot about some of the issues associated with AI in terms of using it. That is going to be an ongoing discussion. There's always going to be policy associated with that. So make sure you keep thinking about those things. Somebody asked if they can have a copy of all the resources. I've been keeping a track of that. So I believe that there's going to be a Google Doc, and we'll paste those in there. And watch soon for the AI facilitation working group resources as well. Okay, well, if there's not any final questions or comments, I'm going to turn it over to Henry and give him a couple minutes to close out the session and talk about the logistics and what's coming up. Henry? Oh, yes,
All right.
definitely. And,
What?
and definitely, I need to thank all our panelists and especially Paul for setting things up. Thank you, panelists, and I appreciate all your insight into it. Over to you, Henry.
Yes, and thank you all. Let's give our panel a round of virtual applause. We very much appreciate the panel, the topic, the content, the discussion. And you can see from all the activity in the chat how engaged everyone was. So I'm really happy about this. Thank you all for doing such a wonderful job. And I want to give a quick preview of coming attractions. Our next session starts in 33 and a half minutes. So at quarter till the hour, Dirk Colbury will be doing how to do an intake interview along with intake interview demonstrations. So this will be a very exciting opportunity to learn about what to do the first time you meet with a user you've never met with before. And yes, I agree with the comment in the chat that Dirk is fun. So thank you, Paul, for putting that in there. And we're looking forward to seeing you. We will keep the Zoom session live, so just stay logged in. Take your bio break, refresh your beverage, do your email, whatever all you're doing. Keep us live, and we'll restart again in about 33 minutes. Thank you, everyone, so much for a wonderful session. See you shortly.
Thank you.